Today we're going to be solving systems of equations. However, we're not going to have the typical answer. The typical answer we've had in the past is this one, where we had just one solution. Today we will have two other types of situations, either infinitely many solutions or no solution. So there are three different types of solutions when solving a system of linear equations. One solution is the type that we've dealt with in the past, and so this one would look like this. If we had a line, and then we have another line, and they intersect, the point that they share in common, this point right here, is the point at which they intersect, and that is our solution. So whatever that point is the answer to our problem. Well, we can also have a situation where we have infinitely many solutions. And that means both lines have the same slope and y-intercept. And so if I was to graph one line with a slope and a y-intercept, and then take another equation and graph that, and it just so happens to coincide right along the first line. So they have all those same points. So all that line, that blue line that I just drew over the black line, takes over that whole line. And it shares the same exact points as the black line. So that means we have the same exact line. So when we have the same line, that means we have infinitely many solutions, we say. There's so many we can't even count them. Every point on that line is a solution. And so we'll see a scenario that looks like that. We also have the type where there is no solution. No solutions means they'll never cross. Like here they crossed lots of times. Well, if the lines are parallel, it means they have the same slope, they just never cross. So like here's a line, and we have a line, maybe either above or below this line, but it has the same slope. So we just never get those lines to cross. And we'll see these two situations on page 100 or 353. So let's take a look at one of the types of problems here. So the directions again will say to solve each system, and here this is a good problem for substitution because we have y by itself. So let's take this expression that y is x plus 1, and let's put it in place of y in the equation below. When we do that, we'll rewrite our equation. That second equation, it would go this way, negative x plus y. But in place of y, we're putting this expression, x plus 1. And this all equals 3. So when we do some more work there, something different happens. You see this negative x and this positive x, they cancel out. They make 0. 0x just is 0. And so everything that I have left, well, I can't solve for the variable. I just have numbers. I just bring everything else down. The 0 plus 1 equals 3, so 1 equals 3. Does 1 equal 3? No. And so whenever you use substitution or elimination, and all the variables cancel. So here we substitute in for y, and our variables canceled, and we just have numbers, and they do not equal. So that's the key. When these numbers do not equal here, that means that the lines are parallel. That means they have the same slope. And so that means they will not intersect. Since the lines do not intersect, that means we have no solution. So that would be our answer. And there's a symbol they use for no solution. It's just that 0 with a slash through it. So that would be our answer for this problem. The key is to make sure you show that substitution, show this work, show how the numbers don't equal, and then say no solution. Let's take a look at the next problem. This one, we have another substitution problem. So again, this is a system. We'll have a brace around it showing that these two equations should be solved together. And let's take this expression that y is negative 2x plus 3, and let's put that in place of the y in the equation below. So we'll rewrite our second equation. That would be 2x plus y, but in place of y, we're putting the expression that y is negative 2x plus 3. And then we bring down that minus 3 and the 0 as well. So here, when we do some work, we go ahead and collect like terms. We'll have the same scenario. See the 2x and the negative 2x, that makes 0. But when we collect these two terms, that makes 0 also. So 0 plus 0 is 0. So when we solve and we get the x's and the y's to all cancel, so we have no variables and just numbers, but this time the two numbers do equal. So whenever they do equal, that's when we have infinitely many solutions. So basically what we have here is the same line. So infinitely many solutions would be our answer. And there's a sign or a symbol they use for infinite, and it's just a sideways 8. So it looks something like this. I didn't draw it as well as some people do, but that's what it looks like. And so basically what we have is the same line. And so if we solved for maybe y in this second equation, we'd end up having the same exact line. And that's why the points all coincide. So we have two different scenarios here. On page 353, we're either going to have a no solution, like this one, where the numbers do not equal when we cancel out the variables, or the numbers will equal, and then it's infinitely many solutions. Well, you have one other page, page 384, and that is problems where we do have one solution. So the lines will intersect in one spot, and we will use three different methods to solve.